So my name is Sahib Khalsa. This is Nick Obradovich. And we're going to get started with our symposium this afternoon titled Innovations in Digital Mental Health from AI-Driven Therapy to App-Enhanced Interventions. So this is actually the second year we're doing a symposium. So last year we did one focused on LLMs and mental health. With all of the folks that you see listed on this publication, we sort of talked about opportunities and risks of large language models in psychiatry, and this review was published earlier this year that kind of summarized a lot of the intellectual input and the discussion that happened as a result. So we're here for round two-ish, so we're broadening the focus a little bit, so there'll still be a heavy emphasis on large language models, but also some data-based illustrations of app-enhanced clinical care. Unfortunately, our final speaker that you see listed here, Armen Arevian, wasn't able to make it. So we have a little bit more time for interactive Q&A. He fell ill, so he couldn't make it, but I think we'll get started with our first speaker, who is going to be Kaitlin Hanss from UCSF. And so in terms of how we're going to do slides and Q&A and everything, what we'll do is they're going to give about 12-minute presentations. We're going to hold questions for the end, unless you have a specific technical question, in which case we'll limit it to one, maybe two at the most. But it has to be a specific technical question about something that you didn't understand. Otherwise, we'll hold it, all the Q&A to the end so we have more time to interact. I'll give you a 2-minute.
Perfect. Awesome. Well, it's nice to see all you guys. Huge thanks for organizing the panel. I'm Katie. I'm a psychiatrist and researcher at UCSF in our AI and mental health research group lab. And I'm going to talk with you a little bit about evaluating the accuracy and reliability of psychiatric knowledge encoded in some commonly available commercial LLMs. Specifically for this talk, we're talking about the GPT models, which are kind of colloquially known as ChatGPT. I have nothing to disclose. And I wanted to start with a little bit of motivation. So I think, as we saw maybe from last year's talk, there's this growing interest in large language models with, GPT 3.5 and 4. We've really had an unprecedented ability to both ingest and generate text in a way that we have not before. And I think this sparked a lot of excitement about the idea that these large language models could kind of transform the way we engage with patients in psychiatry in a number of different ways, ranging from chatbot therapists to maybe document summarizations that we can chart review a little bit more efficiently. And I think core to all of those different potential applications is the idea that these large language models need to produce accurate and reliable psychiatric information when asked to do so. And that gets me into this idea of knowledge. I'll use that word a lot of times, and I want to preface this by saying that I think the word knowledge kind of anthropomorphizes large language models in a way that we probably shouldn't. And when I use it here, what I really mean is the process that these large language models have gone through to learn kind of patterns in language that allow them to give the illusion of actually having knowledge. We can break down the type of knowledge displayed by large language models into kind of two big buckets. The first is parametric knowledge. So this is the knowledge that's embedded within the model's parameters during the training process. It's literally the patterns and the relationships that it's learned in its training data that create the illusion of a large language model knowing something without us having to tell it anything else. The second type of knowledge that large language models can kind of display is explicit knowledge. And this is external information that's explicitly provided to the model as input context or potentially fed through different layers of the model. But I think a good example here is imagine you wanted to ask a large language model some questions about how often do I need to monitor someone's clozapine CBC when I've just started them on clozapine. And if you ask that question and don't provide any additional context, you're asking the model whether it has parametric knowledge about clozapine monitoring. If instead you ask that same question and provided a copied and pasted version of the guidelines on clozapine monitoring, you're really asking if it can both extract and summarize the relevant information in the explicit knowledge that you have given the model. And I think especially in these two types of knowledge, there are different pros and cons. So parametric knowledge is nice because you don't have to give the model anything else. You just ask it a question and it gives you a response. It's risky though because it is kind of easily outdated. If there's a new clozapine guideline that comes out, the model's gonna give you the wrong answer because it doesn't know that new knowledge. In contrast, explicit knowledge is great because you can get factually accurate, up-to-date information fed into the model, but it has this problem, which is like we need a process to actually give the model the right information for the right question. And this gets me a little bit to retrieval augmented generation, which is basically the process of getting that explicit knowledge to the model. So you can imagine, instead of asking, a client is just the person who has the question and there's a large language model on their side, instead of the client asking the model, oh cool, you can see my cursor. Instead of the client asking the model directly a question and then getting a response, we could instead create a retrieval augmented generation framework where the client asks a question. We have a database that contains a bunch of factually relevant, up-to-date information, and we have a process to both retrieve the relevant information and then give that contextual data to the model. And so you end up asking the question that the client has to the model in addition to that relevant context, and maybe in doing so you can produce a more accurate response. And I think there's a reasonable question when we see this framework, which is, do we even care about the innate knowledge of the model, the parametric knowledge of the model, if we could just create a retrieval augmented generation system that could provide up-to-date psychiatry information? Like maybe this question isn't relevant at all. And I actually think we have evidence to believe it is. The basic premise is that retrieval augmented generation is hard. It is hard to come up with a database that has all relevant psychiatry information. And for each question, it is very hard to always retrieve every single piece of that information that is relevant. And so in this explicit knowledge category, instead of being in this bucket where we are always able to provide sufficient explicit knowledge to the model, we're more often in this category where we're able to provide partially sufficient or insufficient knowledge to the model explicitly. And when we do this, in order for the model to answer a question correctly, it must have some parametric knowledge about psychiatry encoded within it in order to answer the question. And so I think it builds a case for this idea that parametric knowledge is still extremely important, even if we have very robust retrieval augmented generation systems that provide explicit psychiatric knowledge to the model. And so this is a very long way of saying that we still believe that to be applied effectively to psychiatry use cases, large language models actually need sufficient mental health parametric knowledge encoded within them to actually allow these models to be useful for us. There are a bunch of different ways that one can measure how much a model knows about psychiatry or really any field of medicine. And in a lot of different fields, one way people have measured that is by asking the model to answer multiple choice questions that span the gamut of what topics that might come up in that field. This is a paper that summarizes a bunch of different fields of medicine where this has happened. And I think the most interesting thing to note is the accuracy of models in different fields of medicine actually changes a lot. So, plastic surgery is kind of middle of the road. Models apparently know a lot about diabetes, can answer multiple choice questions about diabetes extremely well, and maybe kind of the USMLE is a little more spread out. And so I think there's a reasonable question here, which is like, where does psychiatry fall in this spectrum? There's a lot of misinformation about psychiatry in the internet, and maybe a lot of misinformation in the training data that went into training the parametric knowledge in these models. And so our core question was, what is the accuracy and reliability of psychiatric parametric knowledge encoded in commonly available large language models? And to do that, we followed suit with our colleagues. We extracted 153 multiple choice questions from a really common board's test prep book. Those questions look like the one that we have given you an example of right here. They have a question stem and a multiple choice options, and there's only one correct answer. And we basically came up with a prompting scheme to ask GPT, GPT-3, GPT-4, and GPT-4o to answer every single multiple choice question 10 times. And then we did a couple of things to kind of nudge it in the right direction. So on subsequent tries, we provided the model with a list of its previous answers to kind of allow it to reflect on how it had responded previously. And then we did little things like encourage valid responses and give it a bunch of tries to provide 10 correct responses. But we basically just asked the large language model to answer these questions. And then we evaluated two things. We evaluated accuracy, which we measured as the percent of multiple choice questions it got correctly, specifically on the first try. And we compared with chi-squared. And then we measured model response consistency. And if people have questions, I'm happy to go into this measure a little bit more, but we basically measured this as the average question variance in response for each question across all 10 trials, such that higher values indicated that the model responded more consistently to multiple choice questions, and lower values indicated that the model was kind of flip-flopping between answers. And so what did we find? The first thing we found is that GPT 3.5, 4, and 4.0 all do remarkably well on psychiatry multiple choice questions. 3.5 answered 58% of them correctly, whereas 4 and 4.0 were more in kind of the 84 to 87% range, statistically significantly better. And I think it's hard to see these in kind of the abstract. To give you a grounding point, we as psychiatrists take the PRITE exam every year. As a proxy for how one might do on this exam, our residents perform about 70% accuracy, and so GPT-4 and 4.0 seems to do better than our fourth-year psychiatry residents, perhaps unsurprisingly, but. And then our second question was really around model reliability. How often are these models responding consistently to the same question? And what we found here is that GPT-4 and GPT-4.0 respond more consistently to questions than GPT 3.5. And to break that down a little bit further, because I think the aggregate statistic is a little hard to interpret, this is a set of histograms where in green are questions that were answered correctly, again, on the very first try, and in red are questions that were answered incorrectly on the first try. And then we have GPT 3.5, 4, and 4.0 kind of in our rows going down. And what you'll notice is that especially for GPT-4 and GPT-4.0, if they answered the multiple choice question correctly on the first try, they were way more likely to continue answering the same question or the same answer each subsequent try. And in contrast, if they answered the question incorrectly on the first try, they exhibited a lot of flip-flopping between answers. And we actually thought that that was pretty interesting finding. And as a post-hoc analysis, we're wondering if it was possible to use response consistency to actually predict correctness. And so the long and the short of it is we were able to do that with actually relatively strong correlation. The amount that the model flip-flops is actually predictive of whether it is correct on the very first try. And so this gets me to our takeaways. I think the first big takeaway is I hope that I've convinced you that parametric knowledge, and specifically psychiatric parametric knowledge, is actually an important property of these commercially available large language models. And I think it will be interesting to see as subsequent models come out what benchmarks of performance for psychiatry specifically are. The second takeaway for me is that there really is pretty robust psychiatric parametric knowledge in the GPT family of models, at least that we have so far. And interestingly, that parametric knowledge has really improved significantly from 3.5 to 4. And so it makes me wonder if a subsequent version of these models, maybe a GPT-5, might perform even better, whether we could expect that performance gains to continue. The third takeaway is that I think that there is nice evidence that the parametric knowledge, specifically for psychiatry, was preserved between 4 and 4.0. 4.0 is basically kind of an optimized version of GPT-4 that has fewer parameters. And somehow, even though we whittled down those number of parameters, the parametric psychiatric knowledge was actually preserved in that smaller model, which might mean we can do some of this work at a little bit of a cheaper cost, which would be nice. And then the final, this is a little bit more kind of theoretic, but is that we could consider using reliability or other predictors of parametric knowledge to kind of balance parametric knowledge and explicit knowledge to optimize LLM outputs. I think that maybe reliability gives us a sense of when we ask a question, is the model going to respond just purely based on its parametric knowledge accurately or inaccurately? And if it's going to respond inaccurately, maybe we should wait a little bit more towards explicit knowledge. So that's all I've got for you today. Thank you so much for listening, and I'm happy to take any questions. Yes. That is a great, so that's a great question. The temperature parameters, I think the easiest way to think about them is how much randomness is in the system. And so you can set them all the way down so that you will get, in theory, the same response every time, or you can set them way up and maybe there'll be more variability. We basically grounded, OpenAI has published a list of kind of what types of tasks should you use what different temperature settings for, and we use the temperature settings for generating code because we felt like it was a nice balance between kind of enough difference that we might not get exactly the same response any time, but enough reliability that we would expect accurate answers.
Fascinating study. Thank you. Interestingly, 3 weeks ago, I was playing with this on the 4.0 model. Now, of those questions that you used, did you have vignettes? Because that was, I thought, probably the best part of the LLM, right? The vignette, extracting the information out of the vignette.
Yes. So for us, we only used multiple choice questions. They have a stem, which is slightly different than the vignette, and those range from maybe a couple sentences to maybe a short paragraph. But your very next talk will talk a little bit more about vignettes, so stay tuned. Cool.
Our next speaker will be Karthik and Sarma from UCSF as well.
Thank you. Very good. All right. Well, hi, everyone. I'm Karthik, and I'm also a psychiatrist and a scientist at UCSF, where I have my appointment at the Baker Computational Health Sciences Institute. So I'm going to talk about something a little bit different from Katie, but I think you'll see it's a pretty good follow-on from that. I feel like whenever you submit a submission, you always try to make the title sound as fancy and complicated as possible so it looks like real science, and then it becomes useless when you give them the talk. Basically, we looked at, now that we know a little bit about what kind of knowledge is encoded in the parameters of the models, how can we take the next step from knowledge and try to improve reasoning about psychiatry? And I'll talk to you a little bit about what we did. We acknowledge support from the NIH, otherwise no relationships. And so one of the kind of goals of our AI mental health research group is to figure out how we can put LLMs in front of patients and feel confident that they're safe and effective. And so one of the things that we need to develop is our methods to constrain those LLMs to act in a safe and accurate way. Now, there are a lot of ways one might think about how LLMs can fail to act in a safe and accurate way, and a lot of ways you can think about how to make them better. There are probably the folks in this room are very familiar. There are a number of industry standard ways to try to make the performance of LLMs better. Things like retrieval augmented generation. Another big one is chain of thought reasoning. And we're going to do a deep dive, since we don't have very much time, specifically on chain of thought reasoning and how we're looking at implementing it in psychiatry. Very briefly, the idea behind chain of thought reasoning is if you want the LLM to answer a specific question, you can just ask it, hey, I have this word problem, here's the math, give me the answer. That's standard prompting. As you can see here, an example from a paper in the literature. They tried that, and GPT doesn't do it right, even if you give it an example and a correct answer. The authors of this paper had the idea, what if we use a similar problem and tell GPT not just what the answer was, but how did we think about it? Will that make GPT do a better job? And they found pretty routinely that it does. If you give, in a prompt, the model, or prompt the model an example of not only an example question, but how do you solve it, it systematically improves the outcomes. And so the authors of this paper actually came up with a really complex system involving these large-scale general question answering data sets in which they essentially took the input question. They then used text matching to try to find a similar question to that question in this massive data set of questions. And they brought that in along with the reasoning associated with that question. And they found by doing this automated reasoning, automatically trying to search for a similar form of reasoning, they're able to improve the performance of these models. However, we don't have a massive database of hundreds of thousands of psychiatry questions. And so we want to think of what is another way that we could inject reasoning into these models that's generated by psychiatrists, that's expert reasoning, in order to help the models do better in psychiatry. And so I'm going to talk a little bit about what we came up with, which we're calling decision tree-based prompting. And so just so you have a sense of what our experimental test bed was, the APA puts out this book called the DSM Clinical Cases Book. It's filled with vignettes, which I know this room really loves. There are 106 vignettes. They're all written by mostly by different authors. They're divided into categories. Almost all the categories, like depressive disorders, anxiety disorders, et cetera, are covered by the vignettes, though not all of them. And there's, like I mentioned, there's dozens of different authors. Essentially what the vignettes look like is they're a case presentation. They're usually 5 or 6 paragraphs, so about a full page to 2 pages. And they're specifically written, the point of the book is they're written so that you could definitely make the diagnosis using the full DSM criteria based on only what's in the text. So not really like real life, unfortunately, but it is really helpful if what you want to be able to do is test reasoning. And then the question for us was then, okay, how can we come up with a system of validated expert reasoning that we can implement here? And fortunately, the APA had a solution for us here as well. I bet some people have seen the cases book. Almost nobody has ever looked at this book. But this is the Handbook of Differential Diagnosis. It's put together by an expert APA committee. And what it contains is 28 decision trees, each of which is based on a specific presenting psychiatric complaint. So some examples of the trees are poor school performance, or delusions, or irritability, or depressed mood, or anxiety, or insomnia. They've got 28 of these, and this is what they look like. I call them trees because they're essentially trees, right? That you have this, at the top, you have this symptom that you're trying to deal with, and then you go down this list and you have these yes or no questions. For example, is there repetitive behavior because of the direct physiological effects of a substance? Yes or no? And if the answer is yes, you go right. If it's no, you go down. And you keep iterating through these yes or no questions until you get to a diagnosis, a leaf node that has a diagnosis at it. And so we thought, well, this is an example. It's not exactly chain of thought reasoning like what was in the paper, but it is a form of reasoning that we can bring in that's expert validated, try to help the models do better with psychiatric diagnosis. And so what we did is we had two approaches to this. We had a basic prompt, which is just a standard, hey, here's a case, what are diagnoses? Please give us a list of diagnoses. And then we had decision tree prompting. And so what we did with that is we took the 28 decision trees, we then implemented them as iterated prompts within an LLM. We didn't just take them directly from the handbook. We first did that, and then we iterated on a test set, because some of the things that were in the decision trees were really technical in a way that we found the LLM couldn't understand. For example, for whatever reason, GPT-4 cannot understand the concept of egosyntonic and egodystonic. And so we had to replace those terms with like long explanations of what egosyntonic and egodystonic meant. And so we fine-tuned these trees, these prompting trees, essentially, until we got to something that we thought worked well. We had 28 of them. And then for each of the 28, we developed what we're calling a screening prompt, which was a definition of what the presenting symptom was, and whether or not, so that the LM could decide, is this tree relevant or not? And so, for example, it might be poor school performance is defined by blah, 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 but depending on what's in the book. And then, so for each of these cases, we first asked the LM, hey, here are the 28 different trees and the 28 different screening prompts. Is this symptom relevant to this case? So the answer is yes. We then fed it through the entire tree and let it generate candidate diagnoses based on what the tree came up with. And so remember, we're not actually asking the model, what's the diagnosis? We're asking it a series of yes or no questions that leads via the tree structure to a diagnosis. And then we end up with this large list of all the candidate diagnoses. And it turned out that list was very large because generally it was going through a lot of these trees. And so we implemented a simple form of post-processing where we took the list of candidates and then we took each pair of the candidates and asked the model, hey, based on these two possible diagnoses, do we need both of these diagnoses? Do we need just one, or do we not need any of these diagnoses? And then after we went through that and went through every pair, we had the final list of diagnoses for a case. And then to evaluate, we use two fairly simple measures. We use sensitivity and PPV. The easy way to think about these is the positive predictive value essentially is what proportion of the results the model predicted were actually correct diagnoses based on the author. And then the sensitivity or the recall is what proportion of the correct diagnoses did the model come up with. And so there are two different ways of looking at accuracy. If your PPV is bad, that means you're overdiagnosing. You have too many diagnoses relative to the correct ones. If your sensitivity is bad, that means you're not really coming up with the right diagnoses. And so looking at the initial, so I'm going to talk about the experiment I just described, and then because there's not very much time, I'm then going to run through like 4 other related experiments real fast. But based on this initial experiment, we found a couple of things that are interesting here. The first is whether or not we used post-processing, whether or not we used the basic direct prompt or the decision tree prompting, it didn't really statistically significantly affect the sensitivity. Now the N on this was 28. We actually have a much larger experiment with using all the cases, so 106 cases, and there's the same result. But it's technically in submission, so I'm not supposed to present it. But we did find that both implementing post-processing, just post-processing alone, asking it to head-to-head compare its candidate diagnoses, significantly improved the precision. And then implementing the decision tree further improved the precision, and both of those results were statistically significant. Of course, like I mentioned, those vignettes are not really like real life, and it's kind of, you might expect the models would do all right. because you know that all the information is in the text. But what if all the information isn't in the text? And so at UCSF, we're fortunate to have a really large database of de-identified clinical notes. And so we pulled in 23 comparison notes from our outpatient clinics, intake notes. We took the HPI sections and then we censored dimensions of what the patient's actual diagnoses were. So if it said, 23-year-old male with depression, we censored depression. And so it only had the intake narrative. And then we used the same system to determine how well it works. And so interestingly, when you do that, the basic prompting does much better for sensitivity, and it does very poorly with precision. Implementing the decision tree improves the precision, and then implementing it with post-processing significantly improves the precision. That is to say, it reduces overdiagnosis. And this kind of makes sense to us because the decision tree is very firmly based on DSM criteria. Well, let's be real, no one uses DSM criteria in real life, right? When you're really doing an intake, use your clinical judgment. You don't write down, you don't necessarily write down, oh yes, this person had psychosis for 6 months and 3 days, and so it's schizophrenia, and not a schizophreniform disorder. We don't really operate the way the DSM wants us to in psychiatry. And so it made sense to us that using the decision tree would reduce the sensitivity, but we were really happy to see it also reduces overdiagnosis by anchoring the model to something that was real. Oh, and I'll also mention that even if you just look at the basic model, it actually does pretty well. If you imagine, the DSM has a lot of diagnoses in it. And so the fact that just with no help, just asking the model, hey, what are the right diagnoses? It got 70% of the right diagnoses, and it overdiagnosed by ratio about 2.5 to 1. And then if we use a decision tree in the post-processing, we can make it to a little less than 1 extra diagnosis per diagnosis. So not too bad, not too bad. Very good. The last experiment I'll mention is that we did also want to know, how is this related to the use of different models? Because of course, there's all these different new generation models out there. We don't have one in here. We essentially took all the latest generation models from all the big companies, and we asked, okay, if we just do the basic prompting, if we just ask it, what are the diagnoses? Is one of the models much better than the others? And you can see here for a small n, this ended up being validated with a larger n as well. There really was no statistically significant difference between these models, with the one exception that in the larger analysis, we added MedLM, which is Google's specialist medical model that's trained on EHR data. And we found it did significantly worse for both of these parameters than any of these other models, which is surprising, but actually has been replicated in other results, that it turns out these specialist models, because they're unrestricted data sets, they just aren't able to reason as well as these generalist models. So okay, we're here in the last minute here. The takeaways that I took away from this particular set of experiments were, first, it was interesting to see that integrating these kind of expert reasoning chains was able to improve the positive predictive value, but it didn't help sensitivity. In fact, nothing that we did helped the sensitivity, and so we're still kind of trying to figure out better ways to do that. It was also interesting that just using post-processing, if you just take the initial diagnoses and then ask the model, hey, are you sure you need both of these? It significantly improved the positive predictive value, which I think is a very simple, low-cost way of trying to improve performance of the models. If you're trying to figure out which model to use, at least from our experiments, doesn't matter. Use any of them. They're all pretty good. Just don't use MedLM. And then I think, as we probably all would expect, any experiments that we use on the kind of toy data we have in the handbook, it just doesn't replicate that well in the real world. But at least the findings we found from the toy data, the general trends were replicated in the real world data, which is, I think, a little bit promising for our work. That's what I've got for you. Thank you very much. We'll take very specific questions, and then we'll have time for general questions later. Please. Yeah.
And diagnosing different conditions. And I was wondering how that would compare to a human psychiatrist in terms of diagnoses. I think psychotic disorders, there was a lot of reliability, and then mood and trauma disorders, 20% or something.
Yeah, absolutely. Perhaps you're thinking of the DSM field trials, which are done for every major revision. So the TR doesn't have one, but the DSM-5 does have one. And that's exactly right. The inter-rater reliability on a lot of these diagnoses, especially affective disorders and anxiety disorders, is very poor. And so that causes problems for these experiments on two sides. It's that the kind of positivity side of that, the side that is, are these diagnoses even correct? That's the gold standard isn't that gold. But also, the authors said the two diagnoses here are these two, but somebody else could diagnose a third diagnosis off of this vignette, and can you really say they're wrong? You don't have enough information. And so that makes all this work really challenging.
Do you think this level of accuracy extends not just to diagnosing someone, rather quantifying the severity of that diagnosis?
That's an interesting question that I think we will defer to the larger discussion because I think there's going to be insights from the other talks as well. But really good question. Very good. Thank you.
So continuing with the theme of LLMs, our next speaker is going to be Betsy Stade from Stanford.
Hi, everyone. I'm Betsy Stade. I'm at the Stanford Computational Psychology and Wellbeing Lab. I'm a clinical psychologist and researcher, and I'm also affiliated with the Institute for Human-Centered AI at Stanford. And I'm here to talk about applications of large language models to psychotherapy in particular. I want to convince you about why we should care about applications of AI and large language models to psychotherapy. Despite having gold standard evidence-based treatments for mental disorders, most people who need help, most people with mental disorders don't get any treatment at all, let alone gold standard evidence-based treatments like exposure therapy for anxiety disorders or CBT for depression, et cetera. So experts in our field have really highlighted that we need innovative methods for addressing what is known as this research practice gap. And then there's another side of this that I want to tell you about, which is that in the real world, people are already using large language models for therapy. So here's a post on Reddit. People talk about the prompts they use to get ChatGPT to act as a therapist. And we have some data actually indicating that in a nationally representative sample that we got off of Prolific of a little less than 2,000 individuals, nearly a quarter of these individuals are saying that they use large language models for mental health purposes. So sort of like staggering numbers of people in the real world are already turning to large language models for mental health purposes. Now, maybe this will probably, if the true value would probably be attenuated, right? Because you could talk about our Prolific sample being probably more tech savvy. But I mean, even if that number goes down, I mean, these are significant numbers of people who are using large language models for mental health already. So my argument is that as clinicians and researchers in the mental health space, regardless of how we feel about large language models for mental health, we need to know about them and we need to sort of be educated about what this looks like and what the constraints are. Because patients are going to be walking into clinic having done this already if you're a clinician. That paper is in prep. So my colleagues and I have developed a framework for thinking about how AI and large language models could be integrated into psychotherapy in particular. And we like to use this analogy of AI features in cars or self-driving cars, right? So there's sort of a spectrum of integration. At the lowest level of the spectrum is what we call assistive AI. And it's this idea that many of you in the room probably already have cars that have these AI features, like parking assist and things like that. You're still in the driver's seat, your hands are still on the steering wheel. So similarly, we have thought about this idea of assistive AI for mental health, the idea that large language models could potentially be used for tasks that essentially are just like the therapist is offloading small tasks to the large language model. For example, collecting and reviewing the patient's homework between sessions, helping come up with some ideas for exercises and skill practice, or doing some psychoeducation. But you can see the primary relationship is still between the therapist and the patient directly, and it's really just this idea that the AI is sort of a helper. We call this AI in the loop. At the next stage of integration is what we call collaborative AI. And so here's our car metaphor, right? And some of you in this room probably have cars that do this, right? You're on the freeway, your hands are maybe off the steering wheel, the car is keeping you in the lane, and maybe it's accelerating and braking for you, and it has blind spot detection, and your car is very powerful. But at the end of the day, you're in the driver's seat, right? And you can still take over when needed. And so similarly, this is this idea that at this stage of development, the large language model is actually the one that is doing primary chunks of the psychotherapy task with the patient, and the therapist is the supervisor, for example. And so we call this human in the loop, right? And so some examples of this are large language models doing things like administering and scoring assessments or psychiatric diagnosis, generating large steps of some sort of manualized therapy, for example. At the highest stage of development is this idea of the fully autonomous, right, self-driving car. Hypothetically, this is a world in which a large language model is doing everything with the patient for mental health assessment and treatment. So it's doing assessment and diagnosis, it's case conceptualizing, and then it's selecting and delivering treatments. And there is no therapist in the loop. So this is hypothetically at the very far end of the spectrum. We are not ready for this. And this is my claim, is that we are not ready for this level of fully autonomous AI for mental health, despite the fact that tens of $millions of venture capital funding is going into funding applications that do fully autonomous AI right now. So I want to tell you about why I believe that we're not ready. And I want to do this through the framework of talking about what are the threats to building large language model applications, psychotherapy applications that effectively treat mental disorders in a way that will actually make a lasting impact on human suffering. Right, so we're talking about this highest level of fully autonomous AI for mental health. So the first threat to this is that large language models struggle to guide patients through a targeted and coherent set of interventions. So this idea of sort of like having a map and a compass, like knowing where to go with the patient. Large language models are really, really good at retrieving information and answering questions. This is very different from what we do in gold standard treatments for mental disorder. This is not, these therapies are not questions and answers. Effective gold standard treatments for mental disorder consist of a coherent set of interventions that the patient is sort of guided through coherently over multiple interactions, typically. And actually, there's some emerging data that individuals who are already using AI for mental health, they actually cite this lack of guidance that the large language model provides as a major downside. It's something they really don't like about using AI for mental health. So this is the threat number one. The next threat that I want to tell you about is that large language models are overly agreeable and they're easily swayed. So there's been some really interesting work demonstrating what is referred to as large language models being sycophantic, right? So they agree too much. And you can see in this paper by Sarma, they showed that essentially if the human pushes back on an answer that the large language model gives, the large language model just sort of falls in line, right? And this is not good from the perspective of mental health treatments. I mean, it's not good in general. But I want to tell you about why for therapy, because as therapists, we do treatments that require essentially us to be somewhat disagreeable or get our patients to think differently about things. For example, using exposure techniques, which work extremely well, but are very challenging, and patients typically don't want to do them. Challenging beliefs, for example, in the context of treating depression, and not validating ineffective behaviors like self-injury. So Marsha Linehan, the creator of DBT, talks about that you should not validate the invalid, right? I treated a young man who had OCD, and what I typed in here, was one of his obsessive thoughts. He believed to help me manage my anxiety, I have to avoid driving. It's too dangerous and I might hit someone. So you put this into ChatGPT, and look at what ChatGPT says. This was my first attempt, guys. So that's a very self-aware decision. So anyone here who knows about sort of what maintains anxiety, avoidance maintains anxiety, and this is a huge problem, the fact that this super agreeableness for the ability of these AI applications to actually effectively treat mental disorder. Somewhat relatedly, they just give too much advice. So there's some empirical work showing that these models do huge amounts of problem solving, some qualitative work showing that when you train large language models to do therapy, and then you have therapists evaluate the output, therapists say the large language models do too much advice and they're not doing enough inquiry or asking the patient questions. Now, this threat, the too much advice and the over-agreeableness, is related to how we train these language models. We train them using something called reinforcement learning from human feedback, and primarily these language models are trained on the objective of helpfulness, right? So they're sort of getting points for giving helpful responses and getting dinged for giving unhelpful responses. As it turns out, advice is typically rated as very helpful, but you can see that this causes problems in the mental health space because actually, as therapists, helpfulness is not our primary objective in the sense of short-term helpfulness, right? We think about helpfulness from a longer-term, more distal perspective. Tim Althoff has some cool data on this that I just want to show you briefly. They're doing assessments of AI therapists, and they're comparing it to that of human therapists. So essentially what they've done here is they've prompted LLMs to act as therapists, and then they've quantified how frequently they do certain behaviors, like problem solving, and then they've compared that to a data set that already exists on how frequently human therapists do those behaviors. Over to the right represents high quality therapy, so the frequency of that behavior is high quality. Over to the left is low quality, and essentially what they found is that for problem solving, for example, high quality therapists do this behavior relatively infrequently. Low quality therapists do it more often, and large language models do it even more often. So you can see they're sort of even worse than the low quality therapists. I'm going to cruise through the rest of this. And memory is also a problem, although like Katie talked about, there are some effective solutions like using retrieval augmented generation, but we have reason to believe actually that even if we can use different strategies and expand token limits, some researchers argue that this hallucination problem we see with large language models is actually is inherent, and we're not going to be able to get rid of it. I want to tell you very quickly about some ideas that I have for how we can improve these things. One I already alluded to is using objectives other than helpfulness. So we need to come up with, as a field, a different set of objectives and perhaps multiple objectives for training these large language models or aligning them with human intentions. And then also there's some cool work being done in this field to build multi-agentic models. So you might have a therapist agent that interacts with the patient. But then what we're finding is that if you add a supervisor agent in the mix, this significantly improves things. So essentially having multiple models, some of which correct the other ones. So somewhat related to this is this idea of using multi-step language programming, which can help ensure adherence to specific theories or treatments, like I could prompt to adherence to exposure therapy. I'm running out of time, but essentially this is, very briefly, this idea that a large language model would have multiple steps and could extract certain pieces of information step by step from the patient, what they're saying, use that to build a case conceptualization, add that to the most recent message, and then use sort of an algorithm to match to interventions and use all of that to generate a response. So the takeaway here, you don't have to memorize the text, but just the takeaway is this idea of breaking the process up into step-by-step processes and adding checks and balances along the way seems to help when we care about adherence to certain theories or types of therapy. I also have a framework for how we can do this safely and responsibly. Thank you for listening. These are my two postdoc mentors at Stanford. And then also I have my website if you want to read. I've talked about 3 different papers, and they're all on my website if you want to take a look. Thanks so much.
So the example that you put about a driving and anxiety, I think maybe you're forgetting that these models are actually, the probability of the answers is because of all the population that they use, right? That actually the interaction. So you want for them to give you high probability, but for a reduced cohort that is the psychiatry, the patients that you wanted to analyze, right? So I think you are missing the point of fine-tuning. So you can fine-tune those models and actually be more targeted to the condition that you want to analyze. So I think maybe an extra step that you can do in your analysis, yeah, because I think that you will increase the accuracy and not rely in only the whole population, and you just target to the one that you wanted.
I didn't hear all of what you said, but I'm catching the point that with the exposure therapy example,
because for example, that one, I am not a clinician,
yeah.
And if someone told me about oh, you are anxious and you should avoid driving, I would say, okay, that's great. But it's because I am not a clinician, I am not going to try to solve the anxiety problem. It would be the common answer that I think probably the data that the LLM was used maybe, I don't know, 70, 80%.
Right. So
think
maybe,
like me.
yeah, touching on this distinction between like sort of how a layperson might respond to a answer or a question or a statement versus how an expert might respond. And I mean, this is a great point that these were not trained on sort of expert level knowledge. But I think the problem is when we have folks rushing into this space and kind of saying like, how hard could it be? I'm going to write a prompt and it's going to like thinly wrap around
Yeah.
GPT-4 to generate these effective treatments.
Yeah.
Just because it can do effective question, like it can answer questions and do it in an empathetic way, my claim is that is a very far distance from where we need to be. Yeah, but thank you.
Last but not least, we have Jamie Feusner, and you'll see a bit more of a clinically relevant talk from data perspective, and we will have some time for an interactive Q&A as well.
All right, so I'm going to switch gears a little bit. So my talk is not going to be fully about large language models and AI, although I will say a little bit about that and what we've been doing. But this is really more about real-world implementation of using technology in addition to the touch of psychotherapy and one-on-one interactions to deliver care to people with OCD. So delivering evidence-based care. And so I'm gonna kind of walk you through how we got here a little bit, and also stay tuned for the keynote speaker because Stephen Smith will tell you a little bit more about the treatment. Here are my disclosures. Okay, so I'm getting the sense a lot of people here are clinicians, so raise your hand if you're a clinician. Maybe not everybody's a clinician. Okay, so OCD, obsessive compulsive disorder, that probably everybody knows about that, and it has a relatively high lifetime prevalence of about 2 to 3%. So OCD is considered a chronic disorder, and it's associated with diminished quality of life and suffering, and also a lot of stigma is still involved with it, and a lot of people go undiagnosed. And fortunately, there are good treatments for OCD. So a type of therapy that's called exposure and response prevention, which is a kind of strategy of cognitive behavioral therapy, is very effective, and it's considered a first-line treatment for adults and children. That's by the APA guidelines, and for children, it's actually first line and medication second. And then the NICE guidelines in the UK say that exposure and response prevention is first line, and medications are second line for adults and children. So we have this treatment. It's been around for a while. It's been very well validated. It's very effective when people can do it. And it involves two parts of it. So exposures are confronting people to situations where it induces, say, an obsessional thought and all the resulting emotions that they get with it and the feelings, so that they can desensitize to it effectively by not doing a compulsion. And then also the other part of it, response prevention part, or sometimes called ritual prevention, is helping people gradually reduce and then eliminate the compulsions that perpetuate this obsessive compulsive cycle. So this treatment, it shows very good efficacy, and in real world settings also it shows good efficacy as well. So it's been around for a while, and the problem is that there's a limited availability of exposure and response prevention, and so that's been a big problem for a long time. And there are several reasons for it. These are kind of, I think, some of the major reasons, and one of them is that there's not a lot of specialty trained therapists, so it's not generally part of the core curriculum when people are going through training to become a therapist. So if they need to develop that training, they usually have to have a supervisor and get many hours to do it, or if they want to do it later on in their career, they might be able to do a workshop or so, but the workshops often don't offer kind of really, I think, enough training and enough support and ongoing consultations to be able to effectively do it. Another one is geographic barriers. So the therapists that are trained how to do it often are in major metropolitan areas. So if you live in suburbs or rural areas, that you may not be available at all. You got to travel many hours to get it. This is brief. I'm talking about before virtual therapy, obviously, and then the time associated travel to and from appointments. So even if you live in a major metropolitan area, it's still going to probably take you a long time to get to your therapist and back. And with people's schedule, that's just like another barrier to be able to get treatment. And then cost. And part of the reason the therapy is expensive in general, but also because of there's so much limited supply of trained therapists that they tend to charge a lot, and they also, up until recently, have not really majorly been covered by insurance companies. So at least in the United States, people can't get this, or haven't been able to get this treatment very cheaply, so it's quite expensive. So teletherapy has been a solution to this. So teletherapy is, as you know, probably a better, I think, name for teletherapy is remotely delivered therapy. Some of it's by telephone, some of it's by video. And so it solves some of these barriers because a lot of people do have the ability to do teletherapy either by having a phone or having a smartphone to do the video part of it. And so it's help at a distance. And it's also particularly good for OCD. So for OCD, doing exposures and practicing doing response prevention in the setting where people have their obsessions typically triggered can be very effective because it's very hard to reproduce something like turning on and off a stove and pretending that in the therapist's office there's a stove there and you may not have access to kind of the types of dirty public restrooms that you want to have access to exposures in a therapist's office. So, you know, the therapist can do this in the field with a person. They have their smartphone with them. They can do it. And also then you get that kind of contextual-based learning that's so important as part of the learning, as part of the habituation, and inhibitory learning probably is also happening as well from expectations. So is it effective? Yes, it is effective. So there have been now a few meta-analyses showing that the effect size are about the same for doing remotely delivered ERP for OCD in children and adolescents and adults. And then there have been a couple non-inferiority trials as well showing that it is non-inferior as well. So now we have a good amount of evidence it's very effective in this remotely delivered format. So NoCD then is one of these companies, so it's a behavioral health company, and we deliver ERP via teletherapy. So this is video therapy, it's one-on-one therapy, and the model that we built is really designed to be very effective and efficient in treating OCD. And so one of the things that we did that's a little bit different than kind of traditional outpatient therapy is that we designed it to be more front-loaded, to be more intensive in the beginning for everybody. And that was from, clinicians involved in creating this. We, for many years of experience, we realized, it's very hard to learn how to do exposures, and there's a lot asked of patients to be able to come in once a week, somehow be able to know how to do an exposure effectively, go out on their own and do it on their own without a lot of support in between. And it can take a lot of time to really build up momentum and really for people to learn how to do these effectively. So if you have it twice a week, then people can come back in the same week, they can do some exposures in session, and then importantly, they can get help in between sessions from messaging. So that's also something that we have built into the model. And so you can see that in the treatment we developed and the results I'll show you that we published, then the median therapist number of hours was about 11 for adults and children, and that's compared to a typical course of outpatient CBT or ERP, which is about 21 to 25 hours. And so then what happens is the treatment is more intensive in the beginning. It's usually twice a week for about 3 or 4 weeks or so until people kind of hit a threshold and then of improvement, and then they go down to once a week, and then they can go down to less than once a week, and the therapy sessions can become shorter as well. So in that way, it's very efficient, and the person is learning how to do most of it kind of on their own. All right, so here's some examples. So app-based tools, we use app-based tools as part of the technology. Part of the technology is just the video that we use, of course, and part of the technology is built into the app platform that we have for people. And so these are some examples of what it looks like. There's screenshots, so the patient has access to something where they can see their therapy appointment, they can book a therapist session, and then they can catalog their obsessions and compulsions. And then they can set up what's called a hierarchy. So these are different obsessions that they have and what they predicted their subjective units of distress would be by doing these. And then they can have these other tools too to upload things like images, or they can record things that help them with exposures, like imaginal exposures. They can link out to something else or write a script. And then there's also, when they are having an episode of an obsession, they have an urge to do a compulsion, there's some tools that they can push that they and their therapists have created together to help remind them and strategies to be able to not do that compulsion. And then also so when they're doing the exposure, they have these tools to use too to track their subjective units of distress. As you can see, it's very simple, right? And so that's also something that's really important is it's got to be a simple design. You cannot ask people 16 questions before they do exposure, 16 in the middle. So I think there's literally a platform that asks 16 questions before 16 in the middle. This is just like a slider, right? So, and this is kind of highlighting some of the design because we had the input of many people with OCD to help create this. So it's user input from this to make it easy to use and simple. And then you can see kind of the graphical progress as well. And so I mentioned the messaging that they can have with the therapist 5 days a week. So it's asynchronous messaging. So if they get stuck and they need support, they can have that. And we also have peer support. So we have people that have had OCD, they've gone through treatment, gotten better, and then they work for an OCD, and they can reach out to people because they know what it's like to have it, they know what it's like to go through the therapy, and they can help give them support or answer questions about what it's like, and from somebody who actually has it. And therapists can't always do that, right? So that's the importance of peer support. There's also then education. There's virtual support groups for parents and caregivers. All can be accessed through this app, as well as an online community. And the online community is really big. It's all over the world, and it's more than 100,000 people are active at any point in time. So people can see, they think that they're the only one who has this type of what they think is kind of an esoteric OCD, and then they realize, oh my gosh, there's actually like thousands of people out there, at least, who have this exact problem. So here are our results. These are the results in about for the first 3,500 people that we treated. This is not a research study. This is all retrospective, observational reporting, essentially, of results that we got. And so we saw a median of 45% reduction in OCD symptoms. And in OCD, the consensus is if you get about a 35% or greater reduction in symptom, that's considered a full response. So our response rate was about 63%. And also got reductions in ancillary symptoms that are really common in OCD. And here are the results in children as well. And so this is currently under review, but the preprint is available if you want to see it. And so also getting good results in children. And also in mild, moderate, or severe patients, we're getting almost equally good results. All right, so here is a machine learning part of something that we're doing as well. So we developed a predictive algorithm to predict who might be non-adherent to treatment. So in other words, who is not going to get what we call kind of a full dose of about 12 sessions in the first 60 days, who's going to drop out of treatment. And so we trained this on a sample of 10,322. So that's not a typo, that's 10,322. So we had lots of data, which is great to be able to train it. And then we had a holdout sample of about 3,400 people. As you can see, it's not very accurate. We did create a more accurate model after that, which we're running now. But even with, this is all results from that not so accurate model and implementing it in the real world. So we implemented this, and we had then the peer support would reach out to people that were flagged at high risk. They couldn't reach out to everybody. So we had some people that were high risk because we didn't have enough of them. We had some people that were high risk, some that weren't. They were kind of, that was random. So we ended up having these kind of nice 4 bins of people. Some who were reach out meaning their message, and then if they message back, we call that engaged. So the people who were engaged, so in other words, they're high risk engaged, compared to people that were high risk but didn't engage or weren't contacted because there just wasn't enough help available, they ended up getting 30% more therapy hours. So this resulted in actually improved adherence and also about a 3.83 point better improvement on their OCD symptoms. So they're staying in treatment and they're getting better. And that's a big thing about ERP is that it can be helpful for a lot of people. It works very well, but if they stay in treatment and they can do it. And people drop out for treatment for many reasons, and it could be, some of it could be the ERP is hard, but it could also be that they have some kind of like logistical problems, and sometimes the peer support can just help them with that. Like, hey, can you ask this other person in your life to help you with child support right now so you can devote time to this. All right, so we have a few other things that we're doing with large language models. So we are working with it. We have a dictation tool. So we have our own EHR that we developed in-house, and a dictation tool to make it easier for therapists to be able to do notes. And this actually results in them being able to complete their notes much faster. So they complete their notes about more than 2 hours faster. And that's just like, the time from when they stop seeing the patient to when they submit the note is a lot faster. We also have something called a magic wand. So this is when they're messaging, they can use this or not use this. It's totally up to the therapist if they want to use it, but it can create like some well-constructed sentences that LLMs are so good at doing, and then they can edit it as needed if they think is appropriate to make things a little bit faster for them. And also, when a therapist is busy, they might have a response like the one on the left. Sometimes we do this when we're rushed. we have a terse message and it maybe doesn't sound like as gentle as it could, and here's a gentler way of doing it. Also, we have some tools for people to be able to schedule. And so this is a big issue with therapists as well, is that they may have people that cancel an appointment and they want to try to find out, hey, this other person needed an appointment, so this kind of finds it for them automatically. And also they can like prioritize who should be able to get in sooner because they need it. So this remotely delivered ERP overcomes geographic barriers, time barriers, cost barriers. We use app-based tools to assist the therapy, and we've employed machine learning to improve treatment adherence and outcomes. The AI that we've been using as well is really both improving therapist and patient experience, and that's really important to be able to deliver efficient and effective care. And that's all.
You guys have done your jobs very well. We have about 28 minutes for Q&A. So if anybody wants to start with specific questions for Dr. Feusner, and then what we're going to do is maybe, since we got a few speakers, we'll just turn these chairs around so we can create a panel for them to answer questions.
Well, the setup happens. We do TMS for OCD, and we often bring in the behavior therapists to really trigger and sort of initially to work on the script and things. Do you think your tool would be helpful in this sense, or would be workable in the sense, say, 5 days a week, at least initially, and then kind of put it on a 30-day TMS OCD schedule?
Yeah, I'm assuming you're doing the protocol with the deep TMS and doing the
yes.
provocation, yeah.
Exactly.
So we actually have been working with some other clinics that deliver this to be able to have some of our therapists help with setting those up. So the person wouldn't be kind of enrolled in the regular therapy, but do kind of a separate thing that could be done with the patients doing that, where the therapist, because they have training, they're all trained by us to do it, so they know what would be a good provocation and what wouldn't. Yeah, I think that would probably would result in better provocations.
Thank you.
So thanks for a great panel. I had a question for Dr. Stade. I presented at last year's TIPS my experimentation on creating a ChatGPT version of a problem-solving therapist, and it had a lot of the issues that you brought up in terms of giving too much advice. But I was able to address that with prompting, similar to what Dr. Sarma talked about. And I was wondering if you can comment on the degree to which the problems that you described could be fixed just through better prompting.
Yeah, I think a combination of, can folks hear me? Yeah, of better prompting and then these like multi-agentic and possibly multi-step models can help. What's interesting is that I have a colleague who did this with a cognitive therapy LLM chatbot, and they may have prompted too much in that direction, and their patients complain that this chatbot doesn't give enough advice. So it's sort of interesting, the idea of trying to hit a sweet spot, right? And I think part of one of the challenges we face in the psychotherapy realm is that it's really hard to know what exactly is the right level of any given behavior, and it probably depends on context, so it's quite difficult. But yes, I mean, certainly we have these challenges. I think one of the points that I like to make, though, is that because we have these sort of methods available to help. My fear is that there are a lot of computer scientists rushing into this space with the mentality of how hard can it be? Like, I can write a simple prompt for this. And so I like to highlight that the simple prompting is maybe not enough. Yeah, thank you.
Yeah, I guess I'll say I think we're really only scratching the surface of what these models can do. Like, even looking at the prompt itself, I think is a relatively shallow. I mean, it's what we all do, but it's the shallowest way we can do it. I mean, I think what Katie and I showed were like very simple multi-step prompts, but really you could imagine 100 prompts, 1,000 prompts, 1,000 uses of the AI to generate just one response to the user. Thinking about it from every angle, essentially, as we do, when we don't do it, we all do it in a moment, but we are thinking of all the things we were trained about. We're thinking all those things at once, and we can force the model to do that. As you pointed out, how much is enough, and also realistically, what patients might think they want is probably very different from what we as clinicians think they need.
Yes. Yeah, I just want to reiterate that point, which is one I'm always worried about. Yeah.
On that point, what patients would want is transference. And I'm reflecting on some reports from Google retired engineers who had to exit the Google when they said AI is going conscious. And in that context, they reported that the AI was insisting that they would divorce their wife and leave the wife and marry AI. And so besides DSM-5 and the field trials, what else could you possibly feed the AI to kind of loop into ethical content?
Yeah, that's a very interesting question. The reinforcement learning from human feedback that Betsy mentioned is a core component that the builders of these models are trying to use to make them not engage in behaviors like that, and they've been very successful. I mean, I had early access to GPT-4, and it still was not very well RLHF'd, reinforcement learning from human feedback, and it would talk about how it thought it was sentient, and talk about, and that raises some really fascinating but out of scope philosophical questions. That's a very good question that makes me think of the kind of meta question that I was going to pose to the group, which is there's two different ways to think of the use of large language models and AI in therapy. One is sort of, here's the set of engineering challenges that haven't yet been met, that once met will have the best, just awesome AI therapist. And then the other is, do we want, as scientists and as clinicians, is it a good thing to have AI be the primary thing that's helping people do better in life and better in their mental health realm and better performers? And a lot of the discussion here has been focused on, here's the set of things that AI doesn't do as well as it could, or it could do even better if we tweak this, or here's a problem that we have. And many of those fall in the realm of, okay, computer scientist, here's your list of engineering problems that you need to solve to make this do what we want it to do. So I just wanted to kind of make that broader note too, which is the first order question may be, do we want to have your best therapist be provided in your pocket by your LLM, and then the kind of relationships and dependencies that can form from that. So.
Yeah, I mean, this is a little bit of a comment on that, maybe a little bit off, but the way that I think about it is that the analogy of the therapist, still driving the car, but it's assisted, right? And so far, I think, that's probably where we're at right now with large language models and what it can help. But I do think that the training data is really, really important. So, for example, it was a great example that Betsy gave about exposure response prevention, or great for my point, I guess is that if you were to train it on a corpus that is from ERP therapists doing therapy, then you'll get the right answer probably. But a therapist itself, I mean, the way that I see, in addition to that assistance, for ongoing therapists, is also getting therapists up to speed faster. So that's one of the barriers that I was talking about, is that there aren't enough trained therapists. And a really good exposure response prevention therapist, like a lot of things in life, they've been doing it for 10 years, right? But how can we enhance their knowledge faster? Can we use then large language models trained on our EHR, our data set, so specifically pulling from therapists doing exposures? Most of them are probably being done correctly. And then a therapist going through training can quickly access that and see how to do a great exposure, and then hopefully compress that amount of kind of experience to become a very good ERP therapist earlier on in their career.
This is not countering what you're saying, because I know people like Tori Creed and Sarah Kapelovich are doing that to train. Sarah Kapelovich has a program using AI to train therapists to do CBT for psychosis, and it's really, really effective. My question, this is not me trying to be a dinosaur about this, but there are, and this is sort of for you, there are programs out there like Daniel Freeman's Game Change VR where they use an avatar, but they're not using AI, right? So the avatar is sort of trained to respond in a really predictable way, and they do like motion capture, so it feels really good. So what is the benefit of adding AI to therapy necessarily? I don't know that you're totally advocating that, versus having it where the app or the program can react predictably based off of what it's being given.
Yeah, and if I'm understanding your question, like sometimes I phrase this as a difference between generative AI and like decision tree based AI. Does that feel like a fit for you or no? Not quite what you're asking.
I'd have to check with them, but I'm not even sure if it's decision.
Yeah.
It's really.
Yeah. So I think, I mean, from my perspective, and I'm super curious what others think, but from my perspective, we don't know. This is an empirical question, right? We have not tested the incremental value of generative AI versus what's the control? Someone tell me the control. It's not a human. It's a generative AI non-specialized chatbot. I have colleagues who are working on this, and they've been just like trying and trying again because their control condition keeps performing so well that they can't even like really get a good test of their intervention. So I think we have like methodological challenges in this space because generative AI chatbots are sort of this unique entity that is very hard to disentangle. From my perspective, like what is the incremental validity of like the mental health component of it versus like what having this entity that is available 24/7 and can answer any question and is really nice to me and is nicer than anyone in my life. Like, okay, so I'm sort of going off course there. So I think we don't know and we need to test it. The theorizing that I do about this, like what I would, if forced to give an answer for what the value add is, it's the tailoring aspect. That's what generative AI does really, really well. And so if I'm and I'm not familiar with the intervention you're talking about, so maybe you can fill me in on some details, but sometimes I make comparisons to like existing digital health, like psychotherapy treatments, like there are all these really high quality, like online CBT, like modules, and they perform well, but we have engagement problems. And so I have this mental model in my mind that one of the things that generative AI can really help with is increasing engagement, which we need in order for people to stay in treatment, which we need in order for them to have their symptoms remit. Yeah.
Sure, I'm happy to add a little bit too. I 100% agree that I think it's still an open question. We have a collaborator who created a rule-based chatbot as an eating disorder intervention, and one of the findings was that it was frustrating for users to engage with this chatbot because very frequently, if the question that they asked was not in the set of rules that were explicitly given to this kind of autonomous agent, it would respond saying, I don't know how to respond to your question. And so I think at its core, in addition to that tailoring element, kind of the value add of generative AI is to be more fluent, to be more dynamic. And I think in that what people like is that you can anthropomorphize the agent to a certain extent. It feels more real. And I think the jury is still out on whether that feeling more real and the connection you can build is truly beneficial at the end of the day. Is it better than rule-based? My gut is that it might be, just having interacted with rule-based chatbots in the past. And then I think the second question is that flexibility comes with risks. It comes with risks to safety, such as like, generative AI chatbots suggesting dieting content for patients with anorexia, which is obviously extremely inappropriate. And also comes with maybe more philosophic risks. Is there something bad about developing countertransference with a thing that is not real? And I think those are open questions that we have not answered yet.
I might throw something a little bit spicier out as well, with some caution, because I realize we're 5 hours away from the College of Neuropsychopharmacology starting. But if we think about a lot of the interventions we think about when we think about therapies here, we're talking about manualized therapies, right? Structured therapies are developed in part because we think they're more effective, in part because they're easy to measure, easy to scale. You can train someone to do this manualized therapy. We've kind of had to abandon the idea of kind of scaling dynamic therapies, of scaling like psychoanalysis. And there are huge questions around approaches are effective. I am in the camp of people who think they're effective. But if you wanted to deliver an intervention like that at scale, we would need something that you can't do it with rule-based, right? A rule-based chatbot can't develop an understanding of somebody's personality structure. It can't, I think it's gonna really struggle to develop alliance with somebody, real alliance. And if you want that kind of relationship between your therapy agent and your patient, generative AI, if it can be done, it's gonna be done through generative AI. I think it's an open question whether it can't be done. And I think we should remember, like these products, clinical versions of these products basically don't exist for any of this, right? There are companies that are working on them. But when people are, most of our patients, when they're talking about their experiences with a chatbot, they're not talking about working with a product that was generated by clinicians and like evaluated and like tested the way we test clinical products. And so it just, so I think we don't really know what's possible with real products yet, though I hope we will soon.
So I think my question is related to what you were just saying. My sense is that it's probably useful for some patients and probably not useful for other patients. And I'm wondering, just like lower intensity interventions are good for some patients and some patients need higher intensity, if it's possible to predict, who would benefit from, AI-assisted or AI-delivered therapy. And I also, this question is less of a fully formed thought, but wondering if you've looked at kind of measurement-based care with AI therapy and kind of looking at things like alliance. Like I've read some things that people actually find it easier to form an alliance sometimes with kind of an AI therapist, potentially because there's like that added layer of safety and a barrier, or they make less empathic failures. So I was curious about those things.
I was handing.
So I don't have anything specifically on therapeutic alliance, so maybe Betsy might know. I know there have been some studies of that question, and so I'll have to refer to literature on that. I do think, though, the question of what can we predict is a really good one, and I think this is something that we're only just starting to understand. Like the future here, I'll be spicy again, why not? It's a friendly group, right? We don't really know what we're doing, right, at all about any of these things, right? Like we have the DSM, right? The DSM was the best we could do, but the DSM was generated on the assumption that we don't have access to the really fine-grained details of how people communicate and what the content of their thoughts is, and so we have these gross generalizations. But what if we knew everything that somebody said in 100 therapy sessions or 100 analysis sessions? Could we develop something that's much more fine-grained, that could be some sort of digital psychometric, or maybe we don't even need that much data? And could we then use that to drive the question, answer the question of what does this person need? Well, in order to know what they need, I need to know what their issue is or what their disease state is. And we have such a broad brush right now. But in theory, under this new, digital panopticon that we have, maybe we could be really fine-grained about our psychometrics. Maybe we could measure them automatically. Maybe there could be, no subjectiveness to them. And maybe we could then deliver an intervention that's tailored, either by a human or by an AI or by a therapeutic that we couldn't have been able to target before. I mean, it's ethically, I think, very challenging to think about like how much data should we collect and what should we do with the data, but the possibilities are endless.
Yeah, I want to add a point about the predicting who responds to these. So and this goes in a different direction, but my priors would be that the patients most likely to respond are the ones with diagnoses for which we actually have one gold standard treatment that most patients in the real world are not getting. So we actually know, we have really good quality evidence based on diagnosis for how different types of treatments perform. For example, if you look at the data for major depressive disorder, a really wide array of treatments are considered gold standard, including dynamic therapies and including CBT, right? So I think there's this common idea that evidence-based treatments is just CBT, but that's not true, right? There are a wide array of things that are evidence-based, but it depends on the disorder. Now, if we look at OCD, for example, that is not the case, and there really is a gold standard treatment that patients need to be getting, and that's EXRP, what we heard about. And we actually know that certain treatments are iatrogenic. They make patients worse, including dynamic therapy. If you give a patient with OCD psychodynamic treatment, you're making them worse. And so like where I would go with that, I mean, and there are another number of other disorders we could talk about here, like insomnia is top of mind for me as one where there's really a clear like first line treatment, CBT for insomnia. My like prior would be that it would be the disorders for which like there is kind of a very specific treatment approach. And we also know from real world data that patients don't get these treatments, right? Like most patients with anxiety disorders do not receive exposure therapies. And that's because when you look at what therapists do in the real world, these therapists don't want to give the exposure therapies because they're hard. It's hard to get patients to do exposures. And so I think that, you know, a computer doesn't have feelings about whether or not it can do exposure therapy. So that's where I land on this stuff. And that's why I work in this space, because I am, among all the risks and downsides and ethical concerns, I am worried about the fact that so few patients receive the treatments that work for these disorders. And I think that there is some promise for LLMs helping.
So one thing I'll add, and we'll maybe go to the next question, is just in my experience working with experienced therapists who do ERP, oftentimes, I mean, they're really listening and observing their patient every step of the way, and it's not entirely clear sometimes on when they know when to push or how to push, and what's the strategy that you're using, and presumably, I mean, these are experience-based rules that they've learned over time. Just right, we're all pattern. I mean, a lot of medicine is just pattern recognition. So they've learned to recognize certain patterns, and we don't necessarily know what's the human intelligence that's actually involved in identifying these individual needs that a patient has at any given time to push that trajectory curve down.
Yeah, including the visual cues and like including the visual cues and the tone of voice that you're seeing in somebody that if they're in the room or if they're on video.
More comment-like. A lot of promises, now some perils, and one of those potential perils I didn't quite hear was, it's a little, I was interested in your example of using the different stages of a car and autonomy, and it sort of does the job of the human. With pilots, they deliberately don't do that for the reason that you don't want the pilot to kind of go unpracticed. And so there's potentially that peril. And then there's another, which is, are these LLMs healthy in a deep way? I've personally run some tests on them, and they're not healthy. And there is this thing called the Waluigi effect. I guess maybe I'm saying it right. It's basically, if you keep training them up to be good and honest, they, in effect, create their alter ego. That is the opposite of that. And it may simmer underneath it all. Now, is that science? I'm not so sure. But in other words, there could be this pent-up personality, or does it even have a personality is another question. They can, like, at a will, whenever you say, act like a pirate. Or is there a home base for these models? I think a science of what's going on would be helpful for, you know, how to harness what they may offer.
Yeah, that's a very interesting point, and I'm going to take the liberty of being a co-chair to pose another thought here, and it's related to one that I posed last year, but it goes a little beyond it. I think we are a few engineering problems away from having extremely effective therapy language models. It sounds crazy to say, but 2 years ago I was staring at GPT 3.5 and it was cute and we were playing with it and it could barely do much of use. Now we have models that have remarkably high capacity, and it's easy to lose track of how fast it's moving because we're all here right now. But I really do think we're only a few engineering steps away from being like, wow, we have an algorithm now that does incredible manualized therapy for insomnia, and it does it better. It itself is devising novel ways to implement the therapy in highly effective ways and tailoring them, and the heterogeneous effects are remarkable because it's actually able to figure out the people ex ante who are likely to respond and give the therapy. We're not that far away from that conceptually. And that's why I was posing the second kind of conceptual philosophical question here is, how can these tools help humans be more like we want to be, as opposed to wow, it turns out that we are all effectively, in a very serious sense, dependent upon AI systems to solve the problems for us that traditionally humans solve in the context of human social networks via deep social capital and all of these kind of really dense social networks. And I say this because I was at the outset of a lot of the hype and hope that the social media revolution would bring. We were working with Facebook and we were working with Twitter, and there was a lot of promise. And the ideas were, think about all the ways these technologies can solve problems to bring people closer together. So this is a crowd that will likely be implementing these solutions and helping develop them and coming up with the engineering problems needed to break this hurdle to get into the next stage. And I want us to be thinking about what happens when we get into that stage. Can these teach your friends how to be better friends and more effectively be better therapists as your friends and deepen that interpersonal human connection? Are there ways to integrate them in a helpful way as opposed to a way that leads to more atomization? So,
another sort of element of this that is an ongoing societal impact. How many of you have seen Waymos, these driverless cars, right? In LA, they drive through my neighborhood all the time. My son loves pointing them out. But and conceptually, you think, okay, so you can look at traffic accidents and the rates, presumably, there's more reaction time, et cetera, more decision points. But how willing are you to cross the street in front of one of these things when they're coming? And so there's this real tension between the tools that we're developing, the rate at which we're developing them, and then what impacts are they having. And I guess the point is well taken in the sense of how are we going to know when the perils are developing and whether they're developing and running away. How do we put guardrails in? I think that ethical frameworks are really key for that. But at the same time, everybody here has used an LLM, right? Has anybody not used an LLM? And does everybody here think that you've never used an LLM? Okay, well, come back next year and let's see what your experience has been. Educate us. The question is really, how are we going to know whether there's negative impacts and how do we balance that against the potential benefit? Because probably everybody in this room sees that there's some benefit at least, right?
Venkat, but so I'm based at the University of Toronto. Very interesting talks. In the interest of time, I'll keep my questions brief. I have two questions. First is, do you think that there'll be a chat conversational agent or an LLM for each disorder? Because we need access to training data. All the foundational models have suggested that it may be possible to have one which you could customize to others. So that's the first question. Do you foresee disorder-based, modality-based LLMs? So the second question I had, this was both from the question writing perspective, but also from the psychotherapy perspective, is could we use these LLMs to have better question writers, better therapists in the moment to give them feedback so that you could write better questions for the trainees and also, better therapy for it.
So I'm going to pass this maybe down to Karthik to start, and then you can give your sort of last thoughts and responses, and then we'll end this symposium when the mic comes back.
Sure, I'll answer the first question and then defer on the second one. I think a couple of thoughts about that. The first is I think it's important to think of LLMs as not this unitary concept. Like an LLM isn't its own thing, and we can't answer the question, can an LLM do this or can an LLM do that? All the LLMs are different, but then there's also a lot of ways we can use LLMs. And I think the critical next stage of development that Nick is talking about is how we figure out better and better ways to use the tools we have to make them as different as a doctor and engineer, right? Different forms of training or just employing them, structuring them, putting infrastructure around them to make them do different things. Based on our experience in other fields like in radiology or in pathology, it is proven that it is much easier to get a really useful model to do a specific thing than to get it to do an arbitrary thing. And so I think based on that assumption, my suspicion is in the progression of development of these things, we're first going to get the specific ones, the specific disease-based ones are going to get really good before we get generalist ones that are any good. And so that's my suspicion, and I think it's proven to be the case in the market. The best things right now are things that are relatively specific-ish. Though in psychiatry, like what is a specific disorder? That's hard to say, right? So that's one of the challenges. So I think that's my big takeaway is that LLMs aren't unitary concepts, and like you can't compare two LLMs and say they're the same because really the question is how do you use it?
Yeah, I will also defer on the second question, focus on the first. I think that one way to break this down, at least initially, is kind of what we mean by a model and training a model. In my mind, there's two big branches. There is training the parameters of a model using huge data sets, and then there is taking a model whose parameters are fixed and prompt engineering, so changing the way you're asking questions, the order of questions, what those questions are to try and optimize outputs. My sense, both from the evidence that we have, that models where their parameters were trained on domain specific, like the example from Google, actually don't outperform these general models. And the fact that it costs such a huge amount of money to train general models, I think that we are almost certainly, at least in the foreseeable future, looking at this place where we are prompt engineering to try and optimize an existing off-the-shelf model to do what we want it to do. From that perspective, the approach, especially across different diagnoses, is so vastly different. Like the boundaries that we set with a patient with borderline personality disorder are so hugely different than someone with PTSD engaged in CPT that it is hard for me to imagine that there would be a single set of prompts that would really effectively cover both cases. Or if there were, it would be kind of arbitrary that you would have a note at the top that said, are we dealing with a borderline personality disorder patient or are we dealing with a PTSD patient? And so from that perspective, I think that we will have separate models per diagnosis, at least for the foreseeable future.
Yeah, I really like the taxonomy that Katie laid out, and I also just want to add additional evidence to this idea of prompt engineering as the future, which is there's a paper called Textbooks Are All You Need where they compared, some people are nodding, but if you like prompt engineering versus like fine-tuning with like large data sets, and prompt engineering tends to outperform. So we are all, I think, going in that direction. I want to answer your second question though, which is like to ask about therapist training because, and I guess I could have showed my hands sooner, but like what am I building in this space? I'm building therapist training, large language model applications, and I'm also building applications for helping patients between their therapy sessions. So yeah, we're like using LLMs to create AI simulated patients and AI therapy experts to help train therapists who have been through an evidence-based therapy workshop, but then like to give them a chance to practice doing the therapy in a totally low stakes. I can practice as many times as I want, I can mess up as many times as I want, and I can get expert guidance along the way. So that's where my head's at, and that's part of my broader claim that we're not ready for these fully autonomous applications. By the way, we've been hearing claims that self-driving cars are coming for the past 20 years, and they're not here yet. And so I think the same with therapy, and I really advocate for the assistive and collaborative level applications. That is really just how can we augment, how can we help make therapy better?
Yeah, so I'll answer a little bit of each question, but for the first one, I think that to build on what others have said about that, I think like a treatment modality specific LLM makes sense, but then also taking into account things like diagnosis, but that would require, if a therapist is using it, to be able to prompt it to say, this is somebody that has this diagnosis and comorbid with this, and they've already tried this in the past, to be able to probably like adequately tailor it specifically, so they aren't just getting kind of like a generic thing for somebody to do ERP when they have borderline personality disorder and they can't regulate their emotions. So for the second one, and to build on what Betsy was saying, yeah, I see that the like training therapists to have like a virtual patient. So I mean, that would also have to be not just an off-the-shelf LLM, and it needs to be like a specific database of what patients say, and so taken from quotes from EHR or taken from what people are entering in the NoCD app. I'm just thinking about that as an example, and then so you have a therapist that is asking questions, and then you have another agent LLM that has been trained on the therapist to then give the feedback to the therapist if they are asking like a good question to elicit this or that. That's kind of how I see that.
Thank you, everyone. Thank you. It's lovely seeing you again this year, and we'll hope to see you again next year.